Welcome everybody to today's Tech Talk. I have the tremendous pleasure to announce Kalle and Daniel, which have built this tool that I've been dreaming of for the last, 12 years since I started at MPI. Just a few words on these guys. So Kalle has almost been around all the time for me. Well, he came to MPI from industry where he started first in the CS group, then moved on to the atmospheres. Now he's doing infrastructure. And all the time he's, of course, been doing the choir of MPI.
Not anymore, though.
Not anymore. Well, no choir at the moment. And even those who don't know him probably know MKExp, the tool for setting up the climate model. So Kalle is the guy who builds great, useful things. And he's a great guy. And so it's just great. And Daniel, well, I didn't know him that long, but I got to know him when I started, well, when I've been here at DKRZ. But he studied angewandte Systemwissenschaft, so applied systems sciences, I guess. And then did his PhD on air quality modeling at HZG. And moved on to Warnemünde to IOW. From IOW, where he did biogeochemical modeling, he came to DKRZ and started working on data management. And now he's really responsible for stuff that's related to the tape system. So we'll get a new tape system next year. And so Kalle and Daniel together, and I don't know the details who wrote which line of code, but those two guys did this thing, and it's great and amazing. And I've tried it already a bit, and I just love it. And so the floor is yours, guys.
Thanks for the introduction. Yeah, it's always difficult, even among us, to decide who is doing what. So I'll start first and introduce Daniel. Thanks for being with me. It was a great pleasure to do these things together. We'll just well, the idea is that we sort of do the talk half and half. So I'll do the beginning, and Daniel will take over after about the half. So you have some kind of indication how long you have to listen still and stuff like that. Yeah, this tool we are talking about, we just called it Packem ESMs. We are talking about a tool set for tool suite for archiving Earth system model data, but not only that. So basically, the tool is also meant to be able to pack any data that you might want to move between, say, Mistral and the tape archive and for back again. So it's not necessarily restricted to just the system model data, but of course, this was our main use case. As we said, this is a co-production between MPI and the DKRZ. It's not only the two of us, there was actually a big task force also dealing with this thing. So that's our background, and thanks to all the input that we got from there. You all will know that on Mistral we have a parallel file system divided on Scratch, home, and work, and whereas on Scratch things tend to be removed after 2 weeks, so it doesn't easily get out of space. Work is probably in many projects that you are working on at about 90% or more. So from time to time, it's a very good idea to move these things over to the tape archive, which is also comparably large at DKRZ compared to other computing centers that we have. And what we have here is something we call a HSM system. That's this hierarchical storage management. So that means that we have not only a tape archive, but there's actually also a cache system in front of the tape archive, which then gets moved to tapes and back again. But basically, what we have is a file system for work, for everyday work, and a file system for data that is must currently moved away for whatever reasons. We just look at the reasons later on. And one of the basic things here is that the tape archive expects files to be large to be effective. So we have a maximum file size of 500 gigabyte, but the suggested file size is between 10 and 100. So that means for the time being here, if I have a model that doesn't produce files at this given size, it might be a good idea to pack those files into larger files before archiving them. So why again would we put things on archive? Okay, our work project is full, we have to clear disk space, or the project is coming to an end at all, so we have to sort of apply for a data project and just move data so it is still available, either for backup or for long-time archival because it is needed as basically for good scientific practice that you are obliged to provide your data for at least 10 years in the usual case. So what do we do normally? Well, we got the number of files, bundle them into the tar archives, and copy them via pftp on this HPSS. While this sounds very easy, you all know that this is not exactly easy. First of all, copying data over to the place where we can actually pack the files. Packing them itself takes some while. And after we've just packed the data, there's still pftp to tackle, and it is not exactly what you'd call user-friendly as far as I remember, and as far as most people that told me about it have confirmed. So this is at least this would already warrant a better tool, a better front end. And there is still the other thing that's still not really sure. Once you've passed data via pftp on the tape, you'd still have to check whether the file is really uploaded, because in some cases pftp is known to fail without giving appropriate error message. And then there is this other problem. Once I got the whole bunch of tar files on the tape, how on earth am I supposed to know which file is where after, say, half a year or even longer time? So, two ideas. Maybe I just find I just still know which file is the right. Then I would have to get the whole tar file down and unpack it and just get out the two files I actually need. Or worse still, I have no idea which one of these is the right one, so I don't know. I'd either have a good naming convention and can go back to scenario one, or I have to check all the files and look into them and hopefully find it after, say, 2 or 3 weeks. So this all, I think, and also Florian told us in the introduction that this is something that haunts many people around here. So the idea would be easy enough to have a couple of tools that just take over these tasks and just bundle them into just one. So the first tool that we would have would then just do the aggregation of files into tar files, generate the appropriate commands, and thus doing the tar or the tape, the archiving into packs and the moving of the packs into the archive, possibly or most of the time in parallel, because we've got huge amounts of data and there's no need why I shouldn't archive two big files in serial if I can do it in parallel. And another requirement that we would have is if something fails, we should be able to restart. So if the archive is not completely, or some archive is missing at least, and we are running out of, don't know, computing time or space or whatever, or the system goes down, at least you should be able to start later on without having to begin all from the very first file again. And then we have this other thing, knowing which file to download. And there we went for like two different approaches. One would be just to check whether a certain file is at all existent, or maybe just look into the files and try to find out where a certain data set might be in. And then there's a second tool that actually, after we found out, does the downloading. Similar from the features, similar to what we had for the packing. So we have to look up files. We generate some tftp and in this case untar commands, possibly in parallel and also in a way that could be restarted if there was a failure in between. It might be worth to note that the last two tools share a lot of features in terms of maybe selecting or trying to define which files should be selected from the list for listing or for the unpack. Right. Now, I'm not entirely sure. I think it's Daniel's time now, isn't it?
Actually, yeah. So these tools, which would be nice to have, well, we have them now. They are called packems, listems, and unpackems. The first tool for packing archiving is packems. It was developed by Kalle, and then I came and developed the third tool. And yeah, we have them now running, and today we release them. And in the moment, they are available as development installation on Mistral, but within the next days or within the next weeks, they will be officially installed as an official module. So one background, next slide. One background. Kalle talked about this indexing of files, so that at some point, at some place, there's a mapping saved, which file is packed in which tar archive, and for this purpose we use text files called index files, and you see on the right hand side you see the example folders on the HPSS. Let's say 3 folders: model run A, model run B, model run C, and in each folder there are results archived via tarballs, and in each folder there's such an index file which contains the mapping which original file is archived, is packed in which tarball. And each user has in his home directory a so-called index list file, and this index list file, it contains the path of all available index files. And each time we run packems and a new index file is generated, then this index file is added to this index list file, and it automatically then knows where we have, in which folders we have to archive data and where index files are. If you're cooperating with other colleagues, so let's say in a larger project and someone archives stuff which another person should retrieve later on, then it's necessary that you somehow put your index list files together in some way, or that you put this index list file at some central place for your whole project, so that everyone can add his or her path to his or her index files. And these index files, the nice thing about is you can use all our 3 tools for the purpose of archiving data and retrieving, but you could also have a look in this index text file via text editor or use grep to find stuff in it. So you don't need to use listems or unpackems if you don't want to use it, or if you cannot use it for some reason. Next slide. And with this, we would like to finish with our theoretical part of our presentation. So there's new tool, suite packems, which will be soon available. It's made for the current HPSS system, and as was said at the beginning by Kalle, we will have a new HSM system next year, and it's not fully clear how we will adapt this packem suite to the new HSM. We originally planned a hands-on session after this talk. Mistral was down during the morning. Now we see it's online again, and we are not sure if we. So we actually we plan to make a offline hands-on session, just show some commands locally. Don't know, Kalle, do we want to offer the hands-on session again, or?
Well, I don't know if the Mistral is available again. You say?
Yeah, it seems to be available again. I just tried it.
I'd say go ahead.
Yeah. Okay. So after the questions, we will officially we will finish this talk and have open floor for questions. And after the questions are finished, we will offer a hands-on session for those of you who are interested. We will post some example commands which you can try and provide you some example files which you can try to archive, and or some index files which you can just read with listms and unpackems. If you want to have a look in a detailed help, you find an URL to the official help page here below, and we've also GitLab repository in which we are developing packems. It's I think it's not really available for people, but if you want to join development or whatever, then that's a repository. Next slide. And before we come to the questions, we would like to thank our testers in alphabetical order. Yeah, it was really great that we had testers who made quite some in-depth tests and found a lot of errors. And we hope now we have quite a version which runs hopefully quite bug-free. And also thanks to the DKRZ Beratung, particularly Irina Fast. And with this, I think we are finished with this talk, and we are open to first questions. So if you open the URL, you come to this web page, and so as I said before, Packems isn't installed as an official module on Mistral yet, but Kalle made an installation in his home directory. And so if you want to use Packems now today and maybe tomorrow for testing, you need to follow the instructions given in the setup section. So you need to use the module which is given in Kalle's home directory. I don't know if Kalle, do you want to say something specific to it?
Sorry, I was just looking for somebody wrote that they couldn't open the pad, so I don't know.
Yeah. Sorry.
No, this is not specific. So I don't know whether many people are aware, but it's just possible to have your own module files in your home directory, and that's basically saying that people can use my home directory, my module files from my home directory instead of waiting for the official installation now. But that would be exactly the same. The behavior of the package itself would be exactly the same. Only you can just skip the module use file, the module use line in the first place.
Okay. So. Kalle, do you want to do the hands-on commands, or should I do them? I'm just.
I just do the honors yourself, I'd say.
Okay. Okay. So now I need to share my other screen. Just a second. Okay, now we should see my virtual machine. And I already logged in to Mistral. And I did it already, the things which I listed in setup. And if I have a look at my modules, I've already loaded Packems version 1.1.0. And if you follow the steps given in setup, this notepad, you will also see that we will also have loaded this version 1.1.0 of Packems. And now, if you already worked with HPSS, you know you need a Kerberos ticket to be able to log in via pftp. If you don't have Kerberos activated for your account, you have to request it via the DKRZ Beratung. So then you cannot do this hands-on session now. This Kerberos, it's authentication from Mistral to this table archive, and it's quite secure. Now, these Kerberos tickets, they only have a quite short lifetime, and you have to renew this ticket. So they are, I think, valid in the moment for 2 weeks. And after these 2 weeks, or during these 2 weeks, you have to extend their lifetime. And if the 2 weeks are over, you have to re-get them. There are command line tools for it. but it's a bit nasty if you forget it and you, well, 3 weeks are passed and you are doing all your workflow and suddenly it doesn't work because your ticket is not valid anymore and you have to get a new one and stuff. And therefore Kalle created a nice tool which is called Tape Init. And the actual thing what Tape Init does is it checks if your ticket is still valid, and if not, it applies a new one. Then you have to give your password, and if it's still valid, then nothing happens. And you guys, if it's still valid, you get just information ready for tape operations. So it simplifies the workflow a bit. So, and we created, or we archived already some data in the HPSS. Every user should have reading permissions for this directory, so everyone can use the directory which we provide here as test directory. And there's data archived in this folder. There's an index where index files created, and we have an index list txt. And you see this, it's located, and it should be freely available for reading for each of you. And this index list, it just contains per line one location of an index file at the HPSS. There's a T full stop in front of each pass, and this means that the file is on the tape archive. And the reason for this is that to introduce this, it is that we wanted to allow to have on the one hand side local index files. For example, if I, let's say, work in a train and don't have internet connection, then I can download them to my machine, use systems there. Or on the other hand side, the original planned purpose was to have them in the tape archive. And so if a pass in this list file, if it starts with the T full stop, then it's a pass on the HPSS on the tape, therefore T for tape. And if there's nothing in front of it, then it's assumed that these are local files. So, and if you are adding index files manually, for example, of other working group members of you, and these index files on the HPSS, you need to add this T full stop in the beginning, just for your information. But this is also documented officially in our user documentation. Right, and so I leave this. And we thought we start at first with listms and then go to unpackems and in the end have packems. The reason for this is that if we do some bad packems calls, we might end up with a lot of index files in the archive, and then it's maybe not so straightforward to use this listms calls, or they do not work as we describe it here. Maybe therefore we have this order listms, unpackems, and packems. So there are two ways you can, if you are trying listms on your machine, you can, well, if you don't have ever used packems, then this folder .packems in your home directory doesn't exist, and then the easiest way is just to create this folder and copy this index list txt into your home folder. In my case, I've got already an index list in my home folder, in my .packems folder, and therefore I save my old file and then I copy this new index list file for testing into my .packems folder. And now if this index list file is in this .packems folder, then it's automatically read in by listms. So alternative would be as you see in this notepad to specify with lowercase l and index list file which is located somewhere else. So for example, index list file of some of your colleagues. So, and what we can do now, we just type listms, and before we increase the size of the terminal, and then this listms, it first reads this index list, and from there, and based on that, it retrieves all the index files. Therefore, it takes some time in the beginning. And here we see the content of files that we archived. So this is a quick view. We see in the first column the files, the original files that are archived. In the second column, the tarball in which these files are put in. And then we have in the third column, we have in the path in the HPSS where the specific tarball is located. As you see below here, well, first you see, well, we normally have, for example, netcdf files that are packed in tar archives. But as you see in the bottom row, we could also add tar archives that contain a tar archive. So let's say we have some old data that is archived in the HPSS, and we actually don't exactly know what is in these tar files, but we want to have a simple way to retrieve and unpack these files. Then we can just add these tar files to an index file in the specific folder. And the same would be also possible to add simple netcdf files, right? And it's described in our manual, or if it's not properly described, just ask us and we will explain it or add it to the manual. So we have now this information here. What is archived, and now the problem is we do not want to fill up your disk space with some stuff, and therefore on each call of listms, the index files are newly retrieved, put into a temp directory, and after listms is finished, these index files they are dropped again. And if you want to if you want to don't have this delay in the beginning and do not want to retrieve the index files on each run of listms, you can specify a working temp directory for listms by -w, providing a folder. And then the files, they are once downloaded, so you see it here as a retrieval, they are once retrieved. And if you call it a second time, then they are not retrieved a second time because they are still there. Now, when we run listms, we normally, well, we are looking for some files. And maybe we know, okay, well, I know roughly the name of the tar archive. And I want to filter my tar archives and say, okay, the tar archive in which the data is stored, it starts with data _a, and then there follows something else. And so with the parameter my -a, I can filter the tar archives and say, okay, I want only to consider these archives. And then we can also do the other way around and exclude some archives and say, okay, I know for example this tar archive with number 005 in the end, my data wasn't for sure not in this archive. Then I can also specify this file, and it's excluded from this lookup table. For this filtering, you see I use this bash globs. You can use bash globs, but you can also use regular expressions. If you want to use a regular expression, you need to write an R full stop in the beginning of the expression, and then, well, this star doesn't work anymore, but you need to use regular expressions. Then it's described on the manual page how it works. Right. And now we first filtered only the tar archives, and but we might also want to filter our files, which we have here. And you see we have different types. We have something, it's CMAC written in it. That's a specific atmospheric air quality model, and with EMAP, and it's another one. And maybe you only want to have this EMAP data, and then we just provide in the end of our listms call an expression that filters, says, for example, star EMAP star. Then this output is filtered so that we only get the EMAP files. We could also filter file types, whatever. Right, regular expressions. And if you want to use, so this is a nicely human readable. If you want, for example, to pass this output in another tool directly, you have different output types. For example, you can print out a JSON, and then you get a nice JSON output of this data, and you could also write it with -o directly in a file. To unpackems, actually we try to keep the options quite similar for unpackems. So for example, if I found, let's move this along, and say we didn't want to get this EMAP, but we want to have the CMAC files, then we get only one file here with listms, and now we want to retrieve exactly this file or this search result from listms. We want to retrieve that, then we just replace listms by unpackems. And then if we wish, we can provide specifically a down retrieval folder with -d. So for example, our home directory normally is not a good idea. See what I used here. But yeah, the simplest way would be to say, okay, we just call it this way. Then a make file is generated. In this make file, a pftp command is generated, and this retrieves the file from the HPSS, and then this file, you see it in the bottom row, a tar is called, and the file is unpacked. And now we have in our current location, we have well, and if we don't specify retrieval folder, just retrieve in our current folder. There we see we have a folder called example files A, and this file is stored. And the example file A, this folder, it comes from the folder from which originally came. So the folder tree, it might be saved in the tar files, as you see here at the top, and therefore this folder was also recreated.
We should mention here that the tar file was downloaded from the tape rather fast because we've used it before. But of course, the place where it says get data, that might be the place where you have to wait for the type archive, because it has to load the tapes. So that might actually take a while before you can actually continue with the tar.
Right, and yeah. So and a nice thing is if I call now unpack them second time, then I get at first information, oh, the file already exists that I wanted to extract. And now I can say, okay, I know I want to overwrite the file because the file that already exists is a bad file. Then I can write with -o first. And then I get the information, well, my make, it doesn't do anything. I could ask why. So the point is that unpackems, it remembers which tar archives were extracted already and which tar archives were not extracted. So independent whether we say we want to overwrite files or not, realize, oh, this tar archive was downloaded and was extracted, and I'm not extracting it at all. If I want to go around it, I have to look into this temp directory that I specified with this -w, and there we find case, what was it? Case A. Case A. There we find the downloaded file. So I tried it already before, and therefore I have some garbage still in here. And it is, as you see, there's this tar file that it was downloaded, is stored in this folder. It's data_a_001.tar. And there's another file existing which has the same name, but in the end there's a .unpacked in the end. And these are just plain text files, and they contain just one line. And if these files exist, then it indicates our make file that the tar file was already extracted, and this make rule is not run a second time. So, and if we want to extract this tar archive a second time, what we need to do is that we need to remove this file, and then we can run unpackems the second time to extract files. I just tell it to you as background. We included this feature so that it's possible to restart an unpacking process. So it might be that we want to unpack, retrieve and unpack a quite huge amount of data, and during this process, well, this process might break. For example, we submitted as batch job, and the time of the job was over, and the job quitted. And then we want to restart our retrieval job at the point where it stopped. And therefore, we just introduced this text file so that Packems knows which files were already extracted and which not. And finally, unpackems was made to retrieve files that were originally archived with Packems, but there's also the possibility to retrieve directly tar archives from the tape and unpack them. And for this purpose, we have a parameter -A, and after the parameter, we can specify the path of a file at the tape archive. Here, we have to add a T full stop in the beginning so that unpackems knows it's a tape archive. And then we can, for example, tell unpackems extraction directory for extraction, but what we don't have to. And what happens then is that the index files are ignored, but just this one file which is specified, it's considered, it's retrieved, and it's automatically unpacked to the system. And so it's also possible if you have some old files and you do not want to create an index file. In this case, the file already existed. Right. So this works. So it's possible to just retrieve and unpack old files, and you don't need an index file. And with this, I'm over with my longer presentation. So there's an example directory with some example data. If you don't have data on your hand, you want to use, you can use some of my old data. You see just on my screen, there should be read permissions for each Mistral user. And now a basic task would be, we just want to pack all these data together into one tar archive and put it into the HPSS. Now, in the moment we are on the Mistral login node, and it's maybe not a good idea to do all this stuff on a login node. Therefore, it's a good idea to allocate an interactive node. And we also, for those of you who never did this, is on first it's explained on the DKRZ homepage, but also inserted command here.
Usually, if a file has an error during upload, it should show up in the error messages, and then use an error, create an error in Packems. There's one node, Packems by default tries, if you run it if you run Packems in parallel, it'll try to upload as many files as possible, even if one is failing. If you need it in a way that it should fail at the first file, you can give it another option saying fail fast, and then it'll stop at the first file that creates an error.